Guys, welcome once again to ProSam channel. Here is a home of mathematics. I want to welcome you once again. Continue sharing, liking, and also trying to uh, get through. So what we're trying to do today is just we are looking at De Morgan's law. Now, when we talk about De Morgan's law, we are simply talking about very important maxims that are normally applied in set theory and logic. And this one here tries to explain the relationships between unions and intersections using what we call complements. So what is exactly De Morgan's law? When we talk about De Morgan's law, guys, we are simply talking about a law that states that for any union, for any union of two sets, union of the complements of two sets is equivalent to the intersection of the individual complements. You will understand that, don't worry. I'm saying that this law states that the union of complements of two sets is equivalent to the intersection of the individual complements of those sets. Let's just put that down for us to understand. The saying that the Morgan law states that it states that the union of it states that the union of the union of the complement of two sets is equivalent to the individual complement of the sets. Individual complement of the sets. Now, guys, what do we mean here? In a nutshell, what we are trying to say is that De Morgan's law states that the union of the complement of two sets is equivalent to the intersection, is equal to the intersection, is equal to the intersection of individual complements of the sets. Very, 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 very important. Very important and very easy. Now let's put this in terms of symbols. So we're saying if we have set A union set B, and we are saying this the complement of these two sets. So the complement of two sets, if we get their union, is equivalent to the intersection of the individual complements. So A complement intersection B complement. Correct. Very good. Now, how do we prove this? How do we prove that? Very easy. Very easy. We can do that here. Very easy. The complement of two sets, when we get their union, this one is just simply equivalent to the intersection of the individual complements. Now let's try to prove this. So here we shall let um, so we come and say let x, an element x be we let x be an element of A union B. A union B complement. Let x be an element of A union B complement. So we say so. So what does that mean? This implies that x, x, that implies that that implies that x is not, yeah, that implies that x is not, that is how we write is not an element of A union B. Remember, this is A union B complement. So we are saying down here, we're saying X is not an element. X is an element of A union B complement, the complement of A union B. But now it is not, X is not an element of A union B without the complement. So what does that mean? This implies that we can say that implies that x is an element. X is an element. This implies x is not an element of A, or x is not an element of B. And if x is not an element of A, or x is not an element of B, then it implies that, this implies that x, therefore, is an element of, A complement, and it's also an element of B complement. Are you seeing that? So we're saying, with the De Morgan's law, we're simply saying A union B complement is equivalent to A complement intersection B complement. Individual complements is the same as the complement of the union of the set. But here we are intersecting. So what do we say? We say let X be an element of A union B, which is correct here according to this one. But X is not now an element of A union B without the complement. Then if that is the case, we say therefore X is not an element of A, or X is not an element of B. And what does that mean? It therefore means X is an element of A complement, because if it is not an element of A, then it is an element of A complement. And it is also an element of B complement. Now, we move on and say, if that means if X is an element of A complement and an element of B complement. Remember we said earlier that anytime we use and, what do we do? Can you guess? If we use and, what do we do? We get an intersection sign for and. So in this case, we shall say X is an element of A complement, and because we have and here, we say intersection B complement. And what have we done? We have proved that actually A union B complement is the same as A complement intersection B complement. Perfect. We've done it. Two also, I think, let us again try to dissect the other way round. We can begin with this and still end up with that. So we can go the other way around. Thank you very much. Continue getting deeper and deeper, watching Prof. Sam's channel for more and more. Thank you very much. Enjoy yourself. Bye.